Hello, geometry folks, and welcome to Finding Angle Measures of Polygons. So we're going to begin a new chapter, and this is chapter 11, and we are going to be finding angle measures of polygons, and that is going to lead us into areas and surface areas and different kind of formulas that have to do with polygons. So you need your notebook, a calculator, and a pen or a pencil, and we will get started. Now, if you want, I have attached guided notes onto my website so that you can print them off, as I wasn't there in class to give them to you today. So that will just help you take notes. If you don't want them, you certainly don't have to use them. All right, so we are going to talk about the difference between concave and convex. So I know we've talked about these two vocabulary words before, but we're just going to be reminded of what they both mean. When I look at this first figure, it's a five-sided pentagon or a five-sided figure, and we are going to talk about whether this would be concave or convex. Well, how do we determine if something is concave or convex? Well, what we do is we draw lines on their sides, the exterior, and if the lines cave into the figure, it's called concave. If not, it's called convex. So all these sides are not caving into the figure. So this would be a convex five-sided figure. This, on the other hand, on the other side of this page, if we extend these lines in, do you see how their outsides are extending into the figure? That would be called a concave figure. Now, mostly in this chapter on polygons, we are going to focus on convex polygons. Okay. So knowing those two vocabulary words, we will now move on to what a regular polygon is. So a polygon is many different side figure. So if I was talking about a regular polygon has all congruent sides and all congruent angles. That means all angles and all sides are the same. So equilateral, all sides, and equiangular, all angles, are exactly the same. And if you look over at this figure, each one of these hash marks means every side is the same and each one of the angles is exactly the same. So that would be called a regular polygon. Now, of course, there's polygons that have sides that aren't all the same and angles that aren't all the same. They're just called polygons, not regular polygons. All right, so now we will talk about interior angles of polygons. Now, we know that a triangle is a polygon, and we should know that it's three sides. Now, we've worked a lot with triangles, and when we've worked with triangles, we should know the inside angles of all the triangles. And I believe you would know that the total interior, we're talking about inside, the total angles inside is equal to 180. Okay? We worked with the triangles for a long time, so let's hope we know that. Now we've been working in the past with quadrilaterals. Those are four-sided figures. And with four-sided figures, do we know the total inside? Well, maybe you do and maybe you don't, but we could draw a diagonal, and if we draw a diagonal, we will get two triangles. And every triangle is 180, so 180 and 180 would be 360. So the total angle inside a quadrilateral or a four-sided figure would be 360. Now we could keep going. A pentagon, that's a five-sided figure. And if I drew triangles, so diagonal, diagonal from one angle to another. That would give me 3 triangles. And 3 triangles would give me a total of 540 degrees. Hexagon, that's a 6-sided figure. If I were to try to figure out how many triangles I can make in a 6-sided figure, I can make 4 triangles, and 4 triangles would give me a total of 720 degrees. And that can continue. So a heptagon is 7 sides, and an octagon would be 8 sides, and a nonagon would be 9 sides. I'll move, oops, excuse me. I will move this out of the way here. This would be a 9-sided figure. A decagon would be a 10 sides. And a dodecagon would be 12 sides. Yep, I skipped the 11-side figure. All right, so hopefully you are finding or noticing a pattern as we've gone through and done these figures and the inside of their angles. So if you noticed, a 5-sided figure had 3 triangles, and a 6-sided figure had 4 triangles. How many triangles do you think a 7-sided figure would make? Yep, probably 5 triangles. Okay, and so that brings us to this formula, the polygon interior angles theorem. And this needs to be written down in your notes. But the polygon interior angles theorem says the sum of the interior angles of any convex polygon with n sides is equal to the total degrees is equal to, I'm going to write total degrees here, is the number of sides minus 2 times 180. Because that's how many triangles we can form. Okay? Now, if we are talking about a regular polygon, we can do one step better. We can even talk about each interior angle. Okay? So this one is all interior angles, okay? And they might not all be the same, but if we talk about a regular one, then they're all, each individual interior angle will be the same. And each interior angle degree would be the number of sides minus 2 times 180 divided by how many sides there are. Okay? So both of those formulas are very important. Hopefully you have them written down. Okay, let's do a couple of examples. So example number 1, what is the sum of the interior angles of a convex dodecagon? Well, a dodecagon is 12 sides. Okay, and if we use that formula, the formula says the total degrees inside is equal to n subtract 2 times 180. So the total degrees is equal to 12 minus 2 times 180. 12 minus 2 is 10, and 10 times 180 would be 1800 degrees. So inside a dodecagon, you would have an 1800, total of 1800 degrees. Now you could go ahead and figure out the interior angles of each of the other ones, the 7, the 8, the 9, the 10. Since we haven't done those, you can go ahead and fill that out on your own. All right, so example number 2. If the sum of the interior angles of a convex polygon is 2340, then how many sides does it have? Well, we can use that same formula. The total is equal to the number of sides minus 2 times 180. And then if I would use algebra to solve for n, so I divide by 180. And if I divide by 180, I get 13 is equal to n minus 2. And n minus 2, I need to get n alone, so I'm going to add 2 to both sides. And n would be 15. So this would be a 15-sided polygon. Okay? Example number 3 says, find the measure of the missing angle. Okay? Well, first I need to know how many total sides I have and how much total angle or degrees I should have inside this polygon. So if I count the sides, I have 1, 2, 3, 4, 5 sides. And if you look at your little chart or the ones we just did, a 5-sided figure is n minus 2 times 180. 5 minus 2 times 180 is 540 degrees total. And what we could do is we can take that 540 degrees and add up all the insides and equal it to 540. So 110 plus 92 plus 100 plus x plus 84. So 110 plus 92 plus 100 plus 84 is going to give me 386 plus x. And if I subtract 386, I get x equals 154 degrees. So this angle right here is 154 because all of those inside have to equal 540. All right, now that we've talked about the inside, we now need to talk about the outside. So exterior means outside. So the outside angles are angles you don't typically see, but they are there. So if I extend this side, there would be an exterior angle. If I extend this side over here, this is where my exterior angle would be. If I extend that side, there's my exterior, extend, exterior, extend, exterior. So these are all the exterior angles. Okay? So also you need to write down these formulas for your notes. The sum of the exterior angles of any convex shape always the total exterior degrees, no matter what side of figure we have, is always 360 degrees, no matter how many sides we have. Now, if we have a regular polygon, okay, that means all the inside angles are the same and all the sides are equal, each exterior angle will also be the same. And I can even write a formula for that. So each exterior angle would be equal to 360 divided by the number of sides. N is the number of sides. Okay? So you can find each exterior angle if it's regular by dividing 360 divided by n. All right, let's do an example of finding the value of x given some exterior angles. So I have this polygon. It's actually a quadrilateral. It's a 4-sided figure. And the outside exterior angles always equal 360. So that would be equal to every single one of these added together. So x plus 20 plus 112 plus 96. 360 is equal to 2x plus 20 plus 112 plus 96 is 228. Subtract 228 from both sides, and we get 132 equals 2x. X would equal 66 degrees. Now, does that mean these are all 66? No, it means this one is 66. and this one would be 86 degrees. And if you added those all up, they should equal 360 degrees. All right, so now that we've talked about polygons, inside angles, inside interior, outside exterior angles, we will begin practicing that tomorrow. Thanks for taking good notes, and we'll see you tomorrow.